Good morning, my pre-calc students. We are moving on to chapter 5, which is going to be all about trig identities. So I'm going to go over some of the examples from the book and some key points. The first kind of identities you need to know are the reciprocal and quotient identities, which those you already pretty much know. You should know that sine theta is equal to 1 over cosecant theta. Cosecant theta is 1 over sine theta. Cosine theta is 1 over secant theta. Secant theta is 1 of cosine theta. Tangent theta is 1 over cotangent theta. Cotangent theta is 1 over tangent theta. Those are the reciprocal identities. You already know that. Quotient identities, tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. So the first set of problems asks you to apply those identities. So they're asking you to find cosine x in 1a if secant x is 5/3. So you should know that if you use the identities we just talked about, you should know that secant secant x is 1 over cosine x and vice versa. So if that is true, all you have to do is flip the fraction and you get that cosine x is equal to 3 over 5. It's that simple for this one. Okay. For the second one, they said cosecant beta is 25 over 7 and secant beta is 25 over 24. Find tangent beta. So I know that cosecant beta is 25 over 7, which means if you it means that sine beta would be 7 over 25, and if secant beta is 25 over 24, that means that cosine beta would have to be flipped, so 24 over 25. And now that I have that, I know that tangent is sine over cosine, so tangent beta should be just sine over cosine, or 7 over 25 divided by 24 over 25. This I can just cross out, and I'm left with 7 over 24. Okay, so we move on. And now we have the Pythagorean identities. These are very, very important. They're going to keep coming back over and over again. And the only one that I really memorize is this one, which says sine squared theta plus cosine squared theta equals 1. When I was younger and I had to take tests on this, what I always did was to figure out the other two Pythagorean identities because I didn't have any reference sheets or anything. What I did was I first divided, to get this one, I divided everything by cosine squared theta. So if you have this, if you do divide by cosine squared theta plus cosine squared theta, so if you do that over that plus that over that equals 1. Let me write it better. Sorry, guys. I'll write over here and then I erase it. So to find, if I start with this one, so like I said before, the only one that I really memorized was sine squared theta plus cosine squared theta equals 1. Then to figure out the other two, I would divide everything by, you can do cosine or sine, it doesn't matter. Cosine squared theta, and cosine squared theta. So sine squared theta over cosine squared theta is the same as tangent squared theta, plus this would be just 1 is equal to 1 over cosine squared theta would be just secant squared theta. And that's the second one that you see here. Tangent squared theta plus 1 equals secant squared theta. If you look over here, tangent squared theta plus 1 equals secant squared theta. Okay, and then to get the third, 1 tangent squared theta plus 1 equals secant squared theta. To get the third one, I will just divide everything by sine squared theta. So this is just a way for you not to have to memorize all three of them. You just memorize one, and then you can write on the corner of your paper all the three identities, and you can refer back to them. Okay, so if I divide everything by sine squared theta, you get that 1 plus cosine squared theta over sine squared theta is cotangent squared theta. And 1 over sine squared theta would be cosecant squared theta. So then that's how you'd get the third one here. Okay, cotangent squared theta plus 1 equals cosecant squared theta. All right, so these are the three Pythagorean identities. Let me erase this, and now I'm going to show you how to do some of those problems. Okay. All right. So, 2a, cosecant theta and tangent theta are what they want you to find. They gave you cotangent theta, and they said that cosine theta must be negative. So that's the one that is going to be negative. So I am going, because I have cotangent theta, I am going to use the Pythagorean identity that has cotangent theta, which happens to be this one, the third one. So I am going to say that cotangent squared theta plus 1 equals cosecant squared theta. So cotangent squared theta plus 1 equals cosecant squared theta. And now I just substitute in. Because it's negative 3 squared plus 1 equals cosecant squared theta. This is 9, and 9 plus 1 is cosecant squared theta, which means cosecant squared theta is 10, square root both sides, and you get cosecant theta is square root of 10, and it must be positive. Because this is the reciprocal of the sine function. So I can say that sine theta is going to be 1 over radical 10, and then I can rationalize and get radical 10 over 10. So this is sine theta. Okay, then they want me to find tangent theta, and so I have sine theta, and what else did they give me? I have cotangent theta. They want me, oh, okay. All right, so I already found cosecant theta, and now I am going to, cosecant theta was square root of 10, and now they want me to find tangent theta. Okay, so the reason why oh, I'm sorry, I already had I don't need this. I don't need to change to sine. No need to do this. They did not ask for sine theta. So this is not necessary. And it's correct, but I don't need it. That's not what they are asking. All right, so I have cosecant theta And now they asked me to find tangent theta. I have cotangent theta, so tangent theta should be the one flipped. So tangent theta is equal to 1 over cotangent theta. So that means if cotangent theta is -3, which I was told, then tangent theta should be -1/3. And now I answered both questions. Okay. All right. For the second one, now they're asking me to find, let me use different color here so it's easier to see. Okay. They said cotangent x and secant x, that's what they want me to find. They said sine x is 1/6 and cosine x must be positive. So I am going to use the first one because I was given sine. So I'm going to say sine squared theta or x, doesn't matter, plus cosine squared theta equals 1. So 1/6 squared plus cosine squared theta equals 1. So this is 1/36 plus cosine squared theta equals 1. I'm going to have to subtract, so cosine squared theta is equal to, and I'm going to rewrite this as 36/36. So I have a common denominator, 36/36 minus 1/36. So cosine theta is going to be square root of 35/6. Okay. And did they tell me cosine is greater than 0, so positive. Okay. They want cotangent and secant. So secant x, I just have to flip the cosine. So secant x or theta is going to be 6 radical 35/35 when you rationalize. And then they also asked for cotangent. So cotangent is cosine over sine. I have both. So cotangent theta is cosine theta over sine theta. Cosine theta was radical 35/6. So cotangent theta should be square root of 35/6, all that over sine theta, which was 1/6. So now I can cross this out, and cotangent theta or x should be square root of 35. And that should be, do I have any negatives there? No, they're all positive. Okay, so that's it. So that's how you use the Pythagorean identities. And now moving on. This is just telling you about the cofunctions. In geometry, probably you learned that sine and cosine of complementary angles will be the same. So that's what we have here, okay? So the cofunction identities say that sine theta should be equal to cosine pi/2 or 90 minus theta. Cosine theta is equal to sine pi/2 minus theta. Tangent theta is cotangent pi/2 minus theta. And then and then you also should know that secant theta is equal to cosecant pi over 2 minus theta, and cosecant theta is equal to secant pi over 2 minus theta, because complementary angles for those will give you the same value for the cofunction. Cofunctions, okay. And then odd even identities, sine of negative theta is equal to negative sine of theta, cosecant negative theta is equal to negative cosecant theta. As you can see, those are odd identities, but cosine negative theta is going to be equal to cosine theta, and secant negative theta is going to be equal to secant theta, so those are even functions. Tangent negative theta is equal to negative tangent theta, and cotangent negative theta equals negative cotangent theta. So the only even ones are cosine and secant. Okay. So for this one, they said if sine x equals negative 0.37, find cosine x minus pi over 2. Now this you have to be careful because they didn't say pi over 2 minus x, they said x minus pi over 2. So you know that cosine, these are cofunctions. However, I need to put it in the form pi over 2 minus theta or minus x. So cosine theta minus pi over 2 should be equal to cosine of negative. I can pull out the negative outside to make it in that form. So negative pi over 2 minus theta. Once again, I want this to be positive and that to be negative. So I pulled the negative out, which in turn gives me that this is going to be equal cosine theta minus pi over 2 should be equal to negative cosine pi over 2 minus theta. So the idea here is just to make sure that I have pi over 2 minus theta, not theta minus pi over 2 or x minus pi over 2. So now moving on, I can say that this is going to be equal to negative sine x. So negative sine x, and which makes the value equal to positive 0.37. But now remember, it's not cosine negative theta is equal to cosine theta because it's an even identity. So I can say that cosine negative theta or x, doesn't matter, is equal to cosine theta. So I should say that my answer should be equal to negative 0.37. Okay, now we are going to rewrite, we're going to start simplifying trigonometric expressions. So if they want me to simplify this, there is no rule to follow. You have to use pretty much how you know about the identities to simplify this expression. So what I know here is that if somehow I have a sine, a cosine, I have secant x minus tangent x sine x. So if I can start rewriting this in a manner that I can cancel out some of the trig expressions, that will help me. So I know that secant is inverse cosine. I mean, not inverse cosine, is the reciprocal of the sine function, cosine function. So I can rewrite this as 1 over cosine x minus, and I am going to write tangent x as sine over cosine. So sine x over cosine x times sine x. And now what I get is that this gives me 1 over cosine x minus sine x times sine x is sine squared x over cosine x. And I'm lucky here because the denominators are the same. It's both cosine x. So I can go back to the Pythagorean identities. And I know that 1 minus sine squared x is equal to cosine squared x. So I can rewrite that as cosine squared x over cosine x. And now cosine squared x over cosine x is just going to give me cosine x, because cosine squared x would be cosine x times cosine x over cosine x, and then the top and bottom cosine x would cancel out. So that would be my answer for that one. Just when you simplify it, you get just cosine x. Now this one, they also want me to simplify. I can think, when I look at this problem, I right away think about the co-function identities, because I see that pi over 2 minus x. So I am going to go ahead and say that this cosecant pi over 2 minus x would be the same as secant x, and that's just the co-function identities. So now I am going to say that negative secant x minus tangent squared x secant x is what I'm going to need to simplify. So what I would do at that point, because I have secant x here and secant x here, I am going to factor that out, and I am going to say that negative secant x, and I'm pulling out the negative because I want to get a positive one inside, because that takes me back to one of the Pythagorean identities. So when I pull that out, I get 1 secant x divided by negative secant x divided by negative secant x is 1. And then I would have to have a plus tangent squared x, because if I were to distribute this, then I would get what's on top. Okay? So now I know that one of the Pythagorean identities says that 1 plus tangent squared x is equal to secant squared x. So now I'm left with negative secant x times secant squared x. And now I can just multiply them out, and my final answer is just negative secant cubed x. Okay? Okay. Now they want me to simplify the expressions. These have different denominators. So every time you have a plus or a minus and different denominators, you're going to have to find the common denominator. Okay? So, first one, I am going to do just that, find the common denominator, because I cannot add the tops together unless I have a common denominator. So my common denominator here is going to be 1 plus sine x times cosine x. I have to have everything there. 1 plus sine x times cosine x. And now whatever is missing in the denominator, I have to multiply the top by. So over here I have 1 plus sine x times cosine x. The denominator here is just 1 plus sine x. So I have to do cosine x times cosine x, which is going to be cosine squared x. And here I'm missing the 1 plus sine x. So I'm going to say 1 plus sine x times 1 plus sine x. You have to FOIL, okay? So like I said before, cosine x times cosine x is going to be cosine squared x plus, you have to FOIL. 1 times 1, 1 times, yeah. So I get 1 times 1 is 1. 1 times sine x plus 1 times sine x is going to be 2 sine x plus sine x times sine x is sine squared x over my denominator. 1 plus sine x times cosine x. And now I'm getting some good stuff here because let's see, I can try to apply some of the identities. Yes, because I know that sine squared x plus cosine squared x is 1. So I can go ahead and rewrite it as 1 plus 1 plus 2 sine x over 1 plus sine x times cosine x. Now 1 plus 1 is 2, so I can just say that this is 2 plus 2 sine x. And I can factor out the 2. So now I have 2 parentheses, 1 plus sine x over 1 plus sine x cosine x. And this is just what I was looking for because 2 is multiplying the binomial 1 plus sine x, and so is cosine x. That's also multiplying the binomial 1 plus sine x. So I can cancel these 2 out. And I'm left with 2 over cosine x. And I try to avoid the fractions, so the reciprocal of 1 over cosine x would be just secant x. So I'm left with 2 secant x. And that should be my final answer. Okay? So careful with the common denominator thing. Moving on. This one. Let's see what I do. I have 1 plus secant x over plus cosecant x over 1 plus secant x plus cosecant x over 1 minus secant x. So I need a common denominator once again. And here we go. So my common denominator is going to be 1 plus secant x. I need more room here. So all right, let me see what I do. Let me just erase and try to get it closer together. Okay. So 1 plus secant x, 1 minus secant x. And same thing here, 1 plus secant x, 1 minus secant x. Okay, so then I'm left with cosecant x times whatever is missing on the bottom, which is 1 minus secant x. And here's going to be cosecant x times 1 plus secant x. Because that's what is missing. So now I need to distribute. So I get cosecant x minus cosecant x secant x plus cosecant x plus cosecant x secant x over 1 plus secant x 1 minus secant x. Now these are going to cancel out because it's negative cosecant x plus secant x, positive cosecant x, secant x. So now cosecant x plus cosecant x is 2 cosecant x. And so I'm going to write that out. 2 cosecant x over, and now I'm going to FOIL this guy here on the bottom to see if I can use any of the identities. So that would be 1 times 1 is 1 minus secant x plus secant x would cancel out, so minus secant squared x. And 1 minus secant squared x actually equals 1. No, sorry. 1 minus secant x is equal to negative tangent x. Tangent squared x? Tangent squared x. Okay. All right, so I can rewrite that as 2 cosecant x, negative 2 cosecant x, cotangent x, because I avoid fractions when I do this. So let me just do this. So we're gonna get 2 cosecant x times negative cotangent squared x. And I can also write that as negative 2 cosecant x or cotangent squared x, doesn't matter, cosecant x. There you are. Now, you might also be asked to eliminate fraction. It says rewrite as an expression that does not involve a fraction. So what you need to do here is make sure that your denominator is 1. So what I would do is I would rewrite this. I know that cosine squared theta is equal to 1 minus sine squared theta because sine squared theta plus cosine squared theta equals 1. So I'm going to rewrite that as sine 1 minus sine squared theta. The reason I do that is because I want to get sine on both top and bottom and hope that I'll be able to cancel out something along the way. So 1 minus sine squared x over 1 minus sine x. And now I know that I can factor 1 minus sine squared x because that's the difference of two perfect squares. A lot of algebra 2 stuff here in this section. So this is the same as 1 plus sine x times 1 minus sine x. And now what I was hoping for just happened. 1 minus sine x. Because 1 plus sine x is multiplying 1 minus sine x. So I can cancel out these two binomials. And my answer now is 1 plus sine x over 1. I'm good. And then for 7b, I don't see much there that I can do as far as canceling out or simplifying. So I'm just going to go ahead and multiply by the conjugate. So remember, as long as I do the same to both top and bottom, I'm still gonna get an equivalent ratio. So secant x plus tangent x. And if I want to get rid of, it's just like when you have a radical in the denominator, you multiply by, you try to cancel out the radical. Or sometimes if you have like 1 plus square root of 2, 1 minus square root of 3, you'd have to multiply by the conjugate to get rid of the radical in the denominator. Here I'm going to multiply both top and bottom by secant x minus tangent x. And I'll do the same to the bottom, secant x minus tangent x. And when I do that, on the bottom, I get, well, this is just, I have to make sure that I distribute. So I get 4 secant x minus 4 tangent x. And when you FOIL that bottom, remember, you got to FOIL, always FOIL. You get secant squared x, and then it would be minus secant x tangent x plus tangent x secant x, so those would cancel out, minus tangent squared x. And just for my luck, this is a Pythagorean identity. Secant squared x minus tangent squared x is 1, I believe. Secant squared x minus tangent squared x. Secant squared x minus tangent squared x. Yes, secant squared x minus tangent squared x is 1. So that equals 1. So I can go back there and I can simply write a 1 for my denominator, or just don't write anything. So I am good, and my final answer should be 4 secant x minus 4 tangent x. There you are. I think, is that it? That's it. Okay, well, have a great day and see you next time. Thank you.